Solve the following initial value problem. So we have xy squared dy over dx equals y cube minus x cube, and the initial condition is y at 1 equals 2. So let me write this in the standard form. That is dy over dx equals something. So divide both sides by xy squared and we get dy over dx equals y cubed minus x cubed divided by xy squared. Now the degree on the top is 3 and x 1 2, so this is 3. So we have same degrees on the top and bottom. That means this is homogeneous equation. Okay, so we get homogeneous equation, and this is not separable, as we saw xy squared dy over dx, because y and x, they will be together, so this is not separable. But we can make it separable by the following substitution. So whenever we have homogeneous same degree, then we let y equals, okay, let y equal vx. Then now we replace throughout, we replace y by vx. That is d over dx, derivative of y is vx. In the right hand side, y cubed means vx cubed, so v cubed x cubed minus x cubed over x times y squared. Y squared means v squared x squared. Now in the left hand side we have the derivative of a product, so use product rule. So v derivative of x, this is 1, plus x derivative of v, dv over dx. Okay, we found the derivative using product rule. In the right hand side we can factor x cubed on the top, so v cubed minus 1 over x times x squared, x cubed v squared, and we can cancel x cube from top and bottom. So we have then v plus x dv over dx equals v cube minus 1 over v squared, a function of v. So let's move this v to the other side. So subtract v from both sides. So x dv over dx is equal to v cube minus 1 over v squared, subtract v, so minus v. Okay, now let's do some algebra and combine these two fractions. To combine these two, we need to multiply this by v squared over v squared, so that we will have same bottom. So x dv over dx is equal to common denominator v squared. On the top we have v cubed minus 1 minus v times v squared, v cubed, and v cube minus v cube cancel. So x dv over dx equals negative 1 over v squared. Now we are able to separate the variables. Negative 1 over v squared, bring that to the left, so it's a times 1, so v squared goes on the top, negative 1 on the bottom. I am going to leave negative there. Okay, v is on the top, and dv, this x goes on the bottom, 1 over x, and dx. Okay, now we can integrate both sides. Just integrate, we get antiderivative of v squared, v cube over 3 equals minus outside, antiderivative of 1 over x is just natural log of absolute x plus c, and we back substitute v. Here is the substitution we made. Y, we let y be vx, that means v equals y over x. Okay, so v equals y over x, so y over x cubed, so 1/3 y over x cubed, so y cubed over x cubed equals negative natural log of absolute x plus c. But this is an initial value problem, so we need to use this initial condition this given initial condition to determine the value of c. Okay, so using the initial condition y at 1 equals 2, we get y is 2 when the x equals 1. So y is 2, so 2 cubed 8 over 3 times 1 cubed, just 3, equals negative natural log of 1. Natural log of 1 is 0, so negative 0 doesn't count. Just sorry, natural log of 1, which is 0. Okay, this is 0, plus c is c, so c is 8/3. Plug in c equals 8/3 and we get the final answer. This is y cubed over 3x cubed is equal to negative natural log of absolute x plus c. C is 8/3. In fact, you can multiply both sides by 3x cubed and we get y cubed equals this expression. Anyway, this is final.